Alright, grade 10s, here is a lovely easy section of AP, which is equations. Solving for x, we've done equations in the complex number system, so we should be okay with tackling any equation that comes our way. Although sometimes they can look quite scary because they'll be in the form of fractions. Now I'm taking a question from exercise 1 on page 37 of your textbook, but in addition to this, will you please read over example 1 before you complete exercise 1 all by yourself. So here is number C. We need to solve for x, yet this equation has several fractions with different denominators in them. Now, in order to be able to do this, we need to ensure that every single denominator is as fully factorized as possible. You need binomials in the denominator, and the degree of those binomials needs to be 1. Basically, you cannot have an x squared in the denominator or an x cubed. We need to have it as factorized as possible. So for now, luckily, we've been given denominators that are as fully factorized as they can be. So all we need to do is arrange them so that they look the same in order to be able to find an LCD. So all I did there was in the first term after the equal sign, 2 plus x, I rearranged as x plus 2. It's not essential to do that, but it's just more natural. Our eye is used to having the variable come before the constants, especially when later on when we're going to need to FOIL. Then, in order to make all the denominators look the same. In other words, the first denominator before the equal sign is x minus 1. Then this last denominator after the equal sign is 1 minus x. In order to have them look the same, you can flip that binomial round, provided you change the plus to a minus as indicated in red. Now we are ready to find the LCD. The process of this is really, really simple. You go through each term's denominator and you write it down. If you have yet to see the denominator, you write it down. If the denominator has been seen before, you choose the denominator with the highest power. But this one is really simple. So left to right, we see an x minus 1. Then the middle term over there, we see an x plus 2. So that's included. But then the x minus 1 in red is not included again because it's already been written down in the LCD. Now we do exactly as we've done in grade I think probably 8, 9, and 10 equations. We multiply the numerators in this equation with what's missing from the denominator. So this first numerator, x plus 1, has a denominator of x minus 1. Therefore, the part of the LCD that it requires is the x plus 2. Hence, that x plus 1 has been multiplied by the bracket x plus 2. Then we move on to the next term. That 2 at the top is actually a negative 2. So that negative 2 required an x minus 1 from the denominator because it already had x plus 2. And then last but not least, the negative x plus 2 in the last term required an x plus 2 because it already had an x minus 1. So I've just, in the yellow, blue, and green rectangles, I've just linked up the numerators to the part of the LCD that was missing from their denominators. Now it's really easy. All we need to do is FOIL and distribute and simplify as far as possible. The left-hand side, you can use the quick FOIL. You can FOIL out and you should get x squared plus 3x plus 2. The right hand side, we distribute the negative 2 to get negative 2x plus 2. This is wrong. Oh, it's right in the next line. Okay. I've corrected that error in the very next line. Please excuse this. I don't have time to go and edit now because you are about to have your AP Maths lesson. Please note that there's an error in this line, but I corrected it in the next line. And then I distributed the negative into the bracket after foiling the x plus 2 times x plus 2. Right, now we can bring everything over to one side of the equal sign in order to get a trinomial. Typical of AP Maths grade 10, you probably won't be able to factorize this trinomial. So we use our beautiful little magic quadratic formula. Yay! We can see from this standard format of the trinomial, our A value is 2, our B value is 9, and our C value is 4. Now let's substitute all those values into our quadratic formula. Please note it is essential that you memorize this quadratic formula. And here we have it. Negative 9 plus minus 9 minus 4 times 2 times 4. That is going to give us a negative number under the square root sign. So what kind of answers are we expecting for this? Complex non-real numbers. So, reminder, any negative number underneath a square root sign can be written in terms of I. So let's think about this negative 23. It is the same as saying negative 1 times 23, which can be split up into the square root of negative 1 times the square root of negative 3, and then we replace negative 1 with our complex number symbol I, and so negative 23, the square root of negative 23, can actually be written as root 23I. So that's what we pop into our very next line of our equation. And voila, we've pretty much come to the very end of the question. We now, just to show that we realize plus minus represents two answers, we split it up and say x equals negative 9 plus root 23I over 4, or x equals minus 9 minus 23I all over 4. If the question asks you to write your final answer in the form a plus bi, you then just need to split that denominator of 4 between the two terms. In other words, your first answer would be x equals minus 9 over 4 plus root 23I over 4, or x equals minus 9 over 4 minus root 23I over 4. Now you can do the rest of this exercise number 1 on page 37, and please let me know if you have any issues. Good luck.